Okay, so let's take a look at this here and see how we did with some of these word problems. All right, or with this first one at least. Let me use a different color so it stands out here. All right, so 21, again, we're talking about this triangular garden that our mom has decided to design. And we're going to determine the area of the garden in terms of x. So we know that this shape is a triangle, and that's equal to 1/2 times the base times the height. Okay? So, Miranda, what did you say was the base of this triangle? Uh-huh. X plus 1, and then what did you put in for the height?
2x plus 1.
Great. Okay, and that's the area. We could be done here, but the directions also say to simplify our answer. So, Miranda, what do you take that to mean when it says to simplify here? What does it really want us to do here? Yep, exactly. Multiply it out. My recommendation, if you guys didn't hear when I was walking around and talking to different people here, is that you FOIL out the x plus 1 and the 2x plus 3, you multiply those out, and then distribute the 1/2. So I still have the 1/2 that I'm not multiplying out, and then I'll FOIL these things here. So x times 2x, be a parentheses there, 2x squared, and then outer 3 times x, so 3x, inner 2x times 1, so 2x, and then last 1 times 3, so plus 3. So if I simplify that, I get 1/2, like the 3x and the 2x are going to add together. So 1/2 times the 2x squared plus 5x plus 3. Okay? And then what's the last thing left for us to do here to simplify this? Anybody? Multiply the 1/2, distribute it. That's right, Greg, exactly. So we distribute that 1/2. 1/2 times 2, that's easy. It gives us a 1, so just x squared. 1/2 times 5, not so easy. It's like 5 halves or 2.5. I'll leave it as 5 halves. And then 1/2 times 3, again, it's not easy. It doesn't divide nicely. It's just going to be 3 halves or 1.5. Okay, but there is our area. Bless you. There's our area kind of formula there in terms of x. Simplified area formula in terms of x. All right, questions on any of that? We can move on here to letter B. So letter B says, as moms tend to do, she has changed her mind. Okay, that sounds a little like momish, if you know, if you ask me what I'm saying. But anyway, so she has changed her mind and wants to decrease the height by 9 while doubling the base of the garden. What are the new height and new base? I know. Well, moms can be. No, I know. This is more of just a very, you know, not vague, but a very veiled attempt to just be like, here, we're going to change the problem, and now see if you can change it too. So Jake, all right, mom has changed her mind, and she wants to decrease the height by 9. So what would the new height be? Well, what's the old height there, Jake, of the triangle? 2x plus 3. So if we want to decrease that by 9, what should we do with that 2x plus 3? So what? Minus 9. Exactly right. Yeah. So the new height is just going to be 2x plus 3, but then subtract 9. And of course, Jake, with the way that this height was written, we can simplify this sum, right? So what like terms can we combine there? Yeah. And so what will that result in? So we'll have the 2x still and the minus 6. So there's our new height. Okay, and let's do the new base here, and let's see here. What should we do? Let's go to Andrew. So Andrew, the mother here wants to double the base. So the new base is supposed to be doubled. So what was the old base in this case here, Andrew?
The old base.
What was the measure of it? Nope, don't need to. It's in the picture. X plus 1. Very good. We're going to double it, so we'll do twice x plus 1, which simplifies to exactly right, 2x plus 2. So there's the new base. Okay, so new height, new base. Okay, hopefully mom doesn't change her mind again. We'll see here. Okay, so there's our answer. Okay, letter C. Determine the area of this second garden in terms of x. By your answer, or explain your work. All right, so to find the area of this new garden, Katie, how should we go about setting that up?
I just
Into the old area formula? So it's going to be 1/2 times what?
2x.
Very good. Just plug the new base and the new height in. That's all you got to do there. And then it says simplify, Katie, which means, what does that really mean it wants us to do here? Yeah, multiply it all out. Yeah, so let's do the, again, I'm going to suggest we do the two binomials first. Okay, so 2x plus 2 times 2x minus 6. We still have the 1/2 there in front, and we'll just spoil it here. So 2x times 2x, what'd you get there, Katie? Okay, minus 12x. Plus 4x minus 12. Beautiful, well done. Now we'll combine all of our like terms here. The minus 12x and the plus 4x make a, whoops. Well, I'll make it negative 8x. There we go, minus 12. Okay, and then finally we'll distribute that 1/2, which does everything cuts in half nicely. So it'll be 2x squared plus negative 4x or minus 4x and then minus 6. Okay, so there's our new area formula right there. There's our new area formula. Letter D. For what value or values of x will the area of the two gardens be the same? Show or explain your work. For what value of x will the two gardens be the same? So Joshua, if we want to know when the area of these two gardens are going to be the same, how can we set that up in like an equation kind of setting? Yeah. So we'll take this new garden here, 2x squared minus 4x minus 6. That needs to equal what? What's the other thing it should equal? Perfect. Exactly right. That's the old one. So we got the new one, and we're going to set it equal to the old one. And we got to solve this somehow. Okay? Let's see here. Let's see if we can figure out how to solve this thing. Any ideas here about how to solve this? Sorry? Yes, moving something over. Very good. Right. We can't solve quadratic equations unless they're equal to what? Gotta equal 0. No, you're right. Gotta equal 0. We have 0 nowhere over here. So we gotta move things around. Okay? Now, I'm going to recommend we move the things here from the right over to the left. Right? So we'll like subtract x squared from both sides. Okay? So that'll leave us 2x squared minus an x squared leaves us with what? Just an x squared. We still have the minus 4x and the minus 6, and it's still equal to 5 halves x plus 3 halves. Okay? We still have these other two things we got to move over, right? Because we want this thing to equal 0. So let's subtract 5 halves x from both sides. Okay, so that's gone. We now have x squared. Let's see. Negative 4 minus 5 halves. Let's see, that's negative 8 halves minus 5 halves. I mean, negative 13 halves. And then we still have the minus 6, and we still have equals the 3 halves. We have one more thing we got to move. Next step is what? Subtract 3 halves. You got it, Greg. Okay, and so finally we're equal to 0. We're going to have x squared minus 13 over 2x, and then negative 6 minus 3 halves. Let's see, negative 6 is negative 12 halves, minus 3 halves is negative 15 halves, equals 0. Okay, so all we've got to do now is factor this, right? Easy. We just need to come up with two numbers that multiply to negative 15 halves and add to make negative 13. Oh, fractions. Yuck. Yuck, yuck, yuck to fractions, right? No good. No fun. But, Katie?
Just multiply each time.
Yes, we can kind of clear the fraction out of here. We can use algebra here figure this out. Since they're both being divided by 2, if we multiply each side by 2, that'll cancel out those denominators there, and 2 times 0 is still 0, right? So let's multiply both sides by 2 here. Very good, Katie, yes. So we distribute that 2, we get 2x squared minus 13x minus 15 equals 0 still. Okay. So Carlos, how do you like to factor? You use the x? Yep. All right, let's use the x here then. So if this is the thing we're trying to solve, what's going to go on the top of the x? Say again? You have to do 2 times negative 15, so it'll be negative 30. And then what goes in the bottom part of the x? The negative 13, yep, very good. And then here on the 2 side pieces, that's where we're trying to figure out what 2 numbers multiply to negative 30 but add to make negative 13. Say again? Yeah, very good. Yeah, but let's see here. Right, so that's like the crazy thing here, because you look at this, you're like, oh wait, 3 and 10, right? But, right, they don't quite add up right. But the 15 and the 2. So it's going to be positive 15 and negative 2, or positive... Okay, so negative 2 and positive 15. That won't add to make negative 13, that adds to make positive 13. So yeah, positive 2, negative 15. Okay. So there it is. We have one more step though, right? Since we multiplied that 2 back to the negative 15, we got to divide both of these things by 2 as well, right? To kind of undo that. So the 2 and the 2 simplify to 1. Negative 15 over 2 does not simplify. And so this factor is to be what then, Carlos? Based on that information now, what are our factors going to be? Let's see if I can get this to work. So if we have a 1, what's one of the factors going to be? Just plus 1, because it simplifies to the 1 there. And then what is this factor? What does this turn? What factor does this turn into? Nope, close. The 2 becomes the coefficient. It's 2x. Yes, there it is. Yeah, it's been a little while since we've done that, but there it is. Whew. Almost done. We can set x plus 1 equal to 0 now. The 2x minus 15 equals 0. And so x equals negative 1, or x equals 15 over 2. Okay? Questions on that? Now, since we're in a context here, do both of these answers make sense in the context of the problem? Why doesn't the negative 1 make sense in the context of the problem? Right, it doesn't make sense to have a negative measurement. Now, we do have to be a little bit careful because, for example, that negative x value, the negative 1 x value, for example, the first triangle, it's going to be negative 1 plus 1. But still, that really wouldn't make sense because you're going to have a 0 for the base, which wouldn't make any sense. Negative 1 in here would still make sense. 2 times negative 1 would be negative 2 plus 3. It would still give us a height of 1, but there would be no base. And so, yeah, no negative 1 solution here. It's really just the 15 halves. That one does make sense in the context of the problem. Okay? But well done there, Greg. Yes, you want to be on your toes about that. 15 halves. All right. Questions on any of that? So that's something we should be kind of prepared for on the test coming up next week. Okay. There's a very good chance to see a question like this again. This is not the last one of these that we'll see. We'll at least have one more on the review for the test too. But I can guarantee you'll see one like this in the test. So you want to be ready for it. Okay, you want to be ready for it. All right. This is all stuff that we've done. I don't think it's out of the realm of possibility for any of you guys here. But just maybe take a little more practice. Especially this one. There's so many steps involved here. It's very easy to make a little mistake somewhere and then get messed up. But it's possible. Okay. if we were allowed to use our calculators here, how could we easily solve this equation? You guys remember I told you that you can solve any equation using these graphing calculators? What do you have to do? Do you remember? Yes, exactly right, Katie. If you graph the left-hand side and graph the right-hand side, watch this. I'll do it real quick since we're here. Okay, so the left-hand side, I'll put in y1, 2x squared, minus 4x, minus 6. And I'll put the right-hand side in y2, x squared, plus, and I'll put parentheses around the 5 halves, plus parentheses around the 3 halves. And we'll graph. There's the left-hand side. There's the right-hand side. You can see one of the points of intersection right there. So I press second trace and go to the intersect command. And let's see, there's my little targeting cursor. It's on the first curve. Now it's on the second curve. And it says guess, so I'm going to move it in close to that intersection point for the guess. And what do you know? There's one of our solutions. You can barely see it. There it is, -1. You can see that they're maybe going to intersect. They're going to maybe intersect further up here, so we have to adjust our window. Which part of our window do I need to change here? If I want to go up further, which value here on my window do I need to change? The Y what? Max. So I'll go up to like 20 here, and let's see if I can find that point of intersection. Okay, again, there's the left side of the equation. There's the right side of the equation. Ooh, 20 was not enough. What should I try next, you think? I did 20, so what else? What should I try next, maybe? 30. 30? All right, try 30. Let's see what happens. First one. Second one. Oh, not yet. What should I try now? 50. There you go. I think it's a good idea. Jumping up by 20 maybe this time. Let's see. Oh! All right, I'm going to do 100 now. Just forget it. 100. First one. Whew, just barely, but it did. All right, so now again we go to intersect. Okay, first curve, second curve, and then don't forget you got to move that for the guess. You really want to move in close to where that 0 is, otherwise it may guess the other one. And there it is, 7.5. That other answer we got. 15 halves is 7.5. Same thing. Okay. So if you have graphing calculators here, you can solve this using that graphing calculator. Okay? Solve using a graphing calculator. All right, next one, 22. Let's read through this. A baton twirler releases a baton at a height of 5 feet above the ground. Right? We had a baton twirler in our pep rally in the fall. You guys remember that? It's crazy. Anyway, a baton twirler releases a baton at a height of 5 feet above the ground with the initial velocity of 30 feet per second. The height of the baton t seconds after it is thrown is given by the function there, where h of t is the height of the baton in feet. Graph the function on the graph below. Be sure to label the axes appropriately. So, what I would like you guys to do right now, what are some things that we normally find when we want to graph a parabola? What's an important point that we find? Let's go to Patrick. Patrick, what's an important point of a parabola when we go to graph it? Yes. Okay. So, I want you guys to find the vertex of this thing. Patrick, how do you normally find the vertex? Do you use the negative b over 2a? Like,
What's the other one?
the other one is like if you, let's see, what's some other things that we do? Well, sometimes we can just look at the function and know what the vertex is if it's written in the right form, but this one's written in standard form, so we wouldn't be able to do it that way. Yeah, I think really the only thing, yeah, because we don't know like the left and the right shifts right now. All we know is that it's, that's our equation. So I think the only way we can do it right now is that x equals negative b over 2a. So find that vertex, I'll say. Okay. Find that vertex. Oops, that's the x value is equal to negative b over 2a. Okay. So go ahead and try and find that vertex, please. Okay, so you get an idea of how, high you're going to have to go or how low it's going to go, right? And then try and graph it. So go ahead, 22a, try and graph this thing. Don't forget to also label the axes. X-axis, Y-axis. Okay? So don't forget to label that too. So go ahead and give this a try. Try and graph this thing, 22A there. Try and graph it. And try to do it without using your graphing calculator. Okay, but just try and graph it. I'll give you like a minute or two here. Try and graph this thing. I'll give you a hint. The vertex is negative b over 2a. Okay, if you need more than that, I'll come around and help too. That vertex. So again, remember the x-coordinate for the vertex is negative b over 2a. So what's your b? What's your a? Plug those in. Try to get that x-coordinate there. Alright, so over there. Oh, that's not a nice number, is it? That seems fancy. Okay. So yeah, so you can simplify that, right? To be like, well, let's do it right here. It's like 15, 16. It's like almost 1, right? Okay. So that's your x-coordinate. Now, how can you use this to get your matching y-coordinate? Or it's not actually, I guess it's t, right? Because that's your t coordinate. So how can you find the matching kind of like y-coordinate to this? What can you do? Well, if this is the x value, you can find the matching y value. So what can you, here's the function right here, right? So if that's x value, what can you do then to find the matching y value then? To find the actual coordinate? You could graph it, you can plug this in, right? Take this, the variable, right? Right, because this, I know it says x, but really it's like the vertex in the x coordinate, which in this case is the t coordinate is like the x coordinate, right? So t is like that. And so the h of t was equal to h of 15, 16. Okay. And then see what you get. Nice numbers. Try and find that vertex. Okay, try and find that vertex there. And again, I said x equals negative b over 2a. Really, in this case, it's going to be t, right? The t is like your x value, and the height, h of t, is like your y value there. Okay? So yeah, so what is the b value according to your function here? Which one? 5. Now that's c, or it's a x squared plus bx plus c. Well, it's t in this case, not squared. A is always with the squared term. The b is with like the single variable, and then the c is the constant. So it would be 30, and then the a is negative 16, right? Unsure about this? So again, the x-coordinate for the vertex, remember, to find the vertex of a parabola, negative b over 2a. So according to our equation here, what's the b value? 30. What's the a value? Negative 16. So plug those in, simplify, and that'll give you the x-coordinate for the vertex, and then you got to plug back in the matching y value. Yes, that's exactly right. Yeah, the numbers are not going to turn out nice, so you can use your graphing calculator to help you simplify things. Okay. This most likely would not be a graphing calculator problem on the test, but I'll make sure the numbers work out a little bit nicer because it's hard to graph just like that. Yes. Yes, to get the matching y value then. Okay, so Andrew, what is our b value here? In this, according to this function right here, what is the b? 30? Is that what you said? 30t, right. Or the b would just be then the 30. So it's going to be negative 30 over, and then 2 times what's the a value in this one? Negative 16, exactly right. So negative 30 is still in the numerator there, and then 2 times negative 16 is negative 32, and then this simplifies to, sorry? Thanks. This simplifies to then 15/16. Okay, now, that gives us the x-coordinate of our vertex, and then we're going to find the matching y-coordinate by doing h of 15/16. And I'm going to use my calculator for that because that's going to be a little bit too messy than what I want to do by hand here. So we'll do, let's see here, negative 16 times 15/16 squared plus 30 times 15/16 plus 5. Whoops, I don't know why I graphed. And 19.0625, or as a fraction, 305/16. No, equals 305/16. Okay, which is almost exactly 19, just a little bit over 19. So it's like approximately 19. Okay. So that's good. Now we know what the highest point of our parabola is going to be, right? Highest point is going to be 15/16, comma 305/16, or about 19. Okay, there's our x, there's our y. So when we go to graph this thing here, what should we maybe count by? Are we going to be able to fit it if we count by ones? No, so let's maybe count by twos here. Okay, so there I got a 20. So that's, past 19. That's good. What's the label for this y-axis here? What is that representing in this case? Okay, what about the feet? And that the feet measures the what? Feet measures time. It's 3 feet past 12. No, that's not time. What's it going to be? It's the what? The height. The height in this case, right? We're talking about a baton. It's going up in the air, right, and back down. So it's feet in height. Height in feet, not feet in height. Goodness. I can't speak. There we go. Height in feet. Okay. What's the x-axis going to be? Time. In what units? Yep. Time in seconds. Okay, so there's the time in seconds. That's on the x-axis, or the t, the z's or t's. Now, what should we maybe count by for our time here? The vertex is at the coordinate 15/16. Ugh, okay? 15/16, which means that it's almost 1. And so if we just count by ones here, that's going to maybe make things a little bit tricky, because if we count by ones, then we're going to be almost, like, the graph will be almost done here. I guess we can count by ones. I guess. Say again? Is it? Okay. So we could count by 1/16, I guess, but then we would only get up to the top and it would never come back down. What can we do here? Maybe we can count... I don't know. What should we count by here? That's a tricky one. Maybe every other one we can count as 1. It's like there's 1, there's 2, something like that, and then 3, and then 4. We're not going to need more than that, I'll tell you right now. Okay. So we know the vertex is 15/16, which is almost 1, and the height is a little over 19. So at almost 1, we're a little over 19. So it's going to be something like this is where our point's going to be. There's our, like, a vertex right there, something like that. Okay. It's not quite 1, right? It's 15/16, but it's over 19, so we have to go a little over halfway. So just a little bit over halfway, something like that. Okay. Let's see if we can figure out some other points here. Let's maybe plug in 0, right? 0 is pretty easy to evaluate, the time of 0. What's the height at the time 0? 5. So that's easy. That's a definite point we've got there. It's halfway between 4 and 6, so there's 5. And then by symmetry, where else will it be at 5 feet? Here's our axis of symmetry right here. Oh, that's going to be not quite right, but well, okay, yeah. If this is roughly at 1, right, this is a little bit before 1, then by symmetry, it would be over the 2, but again, just a little bit before the 2, because it's not quite at 1 there, so we'll say it's something like that is where it's going to be at 5. Okay? And so then we can graph that parabola. Something like that. Okay. Don't worry, folks. I will make this one easier to graph in the future, but this is, an example of something. This is like, it will not be any harder than this, I will tell you that much for sure. But I'll try and make it easier to graph, because these fractions and stuff like that, it's too much, I think. Too much. Okay, so there's the graph. Okay. We labeled the axes appropriately, so you get some points there. Folks, by the way, labeling the axes, even if you screw up the graph royally, it's nowhere right, if you've labeled the axes, that's going to be worth a point right there. So even if you mess with the graph completely, if you have the axes labeled correctly, that's going to be worth something. So please make sure you at least label the axes correctly, even if you don't, if you don't feel confident about the graph. Okay. All right. So now let's take a look at letter B there. So letter B asks, how high is the baton after 1.5 seconds? How high is the baton after 1.5 seconds? So Patrick, any ideas there? We want to know how high is the baton after 1.5 seconds. We don't need to use the graph. We can use whatever information we're given there. So what could we do at 1.5 to figure out how high the baton would be? Any ideas? What do we have that describes the height of the baton in our problem here? So the vertex, okay, is the highest point, right? And this kind of is showing the height of the baton over time. So we could use the graph, okay? Here's 1, here's 2, so 1.5 would be halfway. So we could use it to kind of help us. So 1.5, it looks like it's about 14, About 14 feet. But do we have anything more precise here? Estefani? The function. Patrick, remember the original thing that we were trying to graph there is this function, which will precisely tell us the height at a particular time. So we can also just do h of 1.5. And then that'll be negative 16 times 1.5 squared plus 30 times that 1.5 plus 5. Okay, so let's type that in here. So we get it all fit. All right, -16. Please make sure you use parentheses too when you're typing things in, when you're substituting in. Wow, it is exactly 14. That's pretty impressive. We got very lucky there, I feel like. It is exactly 14. Okay, so good estimate there, Patrick. Okay. 14 is precise on the dot. Okay, and thank you, Estefani, for helping us out there with that one too. All right. So if you turn the paper over, I know it's like not oriented correctly. You'll see that you have letters C, D, E, and F, and then also number 23. Okay, I would like you all to complete the rest of this as much as you can. Okay, so complete C, D, E, and F, and then 23. So complete the rest of these problems here for your assignment tonight. Okay, for your assignment tonight. All right, so complete the rest of the back for your assignment tonight. Yes. All right, so please work on the rest of this, and I'll come around and help you guys as necessary. Okay. You may use your calculators to help you on the one we were just working on.